Let us discuss MOSFET in detail. MOSFET is an electronic device most widely used in ICs. It has three terminals named as source, drain, and gate. Construction of basic design of MOSFET is quite simple. Just take a block of P-type semiconductor. This block will be your base for MOSFET. We also call it as substrate, and the entire MOSFET we will fabricate on this base. Now, two portions on the same side of this P-type substrate are made highly doped with N-type impurity, as these are shown here in the figure. Source and drain terminals are brought out from these two N regions as shown. Now, the entire surface of the substrate is coated with a layer of silicon dioxide. Silicon dioxide will behave here as insulation. On this layer of silicon dioxide, a thin metallic plate is placed. This metallic plate will act as gate contact to the substrate. The gate terminal is brought out from this metallic plate. Hence, it is seen from the figure that gate contact is insulated from the substrate, but drain and source contacts are directly connected to respective N-type regions. This was the constructional feature of a MOSFET. Now we will come to the operational features of MOSFET. For that, we have to connect on DC voltage source between these two N-type regions. The N-type region connected with positive terminal of the source is called as drain, and the N region connected with negative terminal of the source is called as source. As soon as the drain and source are connected with DC voltage source, there will be two PN junctions formed. One is in between N-type drain and P-type base, and the other is in between P-type base and N-type source. As drain is connected with positive terminal of the source, the drain is in higher voltage than base. Hence, this PN junction is reverse biased. On the other hand, as source is connected with negative terminal of the battery, P-type base will be at higher potential than N-type source. Hence, this PN junction is forward biased. As between drain and source, there will be one reverse biased and one forward biased junction. There will be no significant current flowing from the drain to source, but a tiny current continues to flow due to minority carriers. We can say that virtually there is no continuous path or channel between drain and source. Now let us see what happens if one suitable positive voltage is applied at gate terminal of the device. In that case, due to attraction of positive potential of gate contact plate, negative free electrons, that is minority carriers in P-type base, will be accumulated towards a contact plate and form a channel of negative charge carriers even inside P-type semiconductor. This channel, due to higher concentration of free electrons, will behave as N-type semiconductor, although entire base is doped with P-type or trivalent impurity. It is obvious that the number of free electrons accumulated towards gate contact plate depends on the strength of positive potential given to the gate terminal. Hence, width of N channel depends on the voltage applied at gate terminal. More the applied voltage, greater the width of the channel, means greater the conductance between drain and source. Here we have seen that there is no direct connection between gate contact and substrate. Instead, these are insulated from each other. But due to electrostatic attraction, the conducting channel between drain and source is formed, and because of that, the channel is also called induced channel, and the device is called induced channel MOSFET. It is also clear that when there is no voltage applied to the gate of the device, there will be no current from drain to source, except negligible amount of saturation current due to minority carriers. But if the gate voltage is gradually increased by keeping fixed drain to source voltage after certain minimum applied gate voltage, drain to source current will start flowing. And this voltage is called threshold voltage. So, below threshold voltage, the device will behave as non-conducting or in off mode. And for gate voltage greater than threshold value, the device will be in conducting or on mode. So this type of MOSFET is suitably used as a gate control switching device.
Thank you.